Hey, today I'm going to show you guys a video of me making a somewhat silly mistake. Luckily, all I did was waste a little bit of time. But I want to go over my short to ground diagnostic procedure, or kind of the process and the tools I use to do it, and some of the logic I use to come up with the right testing equipment. The first thing I want to go over is fuse ratings. This is a 60 amp fuse. There's a 30. This is a 15, this is a 10, and this is a 5. Now, if I have a short to ground on any of these circuits with these fuses, I'm not necessarily using the exact same equipment. And I'm going to go over why and what happens if you use the wrong equipment or don't understand what you're doing, or in my case, I got in a hurry, wasn't using my brain that day or whatever. So you'll see how easy it is to make a mistake when you're doing this kind of work. So really the mistake I did is I used a test lamp as a current limiting resistor. So like if I was to replace either one of the fuses with a test lamp like this, what I would get is a current limiting resistor. So the amount of current that'll flow through that entire circuit, if this is in place of the fuse, is how much ever current this bulb will allow. In this case, this is a 200 milliamp test lamp, so it's only going to allow 200 milliamps of current through that entire circuit, and that can cause a lot of strange issues, especially if there's switched components on the circuit and stuff like that. So when you're doing testing, it's important to understand what you're doing. So I'm never going to use this type of test lamp in this case. What I'm going to use is something more like these, which are sealed beam headlamps. They pull a lot more current through them, so they have a lot less resistance. So what I want to do, or what I like to do, is like, say I have this 30 amp, I don't know if it'll focus, but trust me. Anyway, green is 30 amp. This is 30 amp fuse. If I have a 30 amp fuse and it burns immediately on key cycle, or if it's always hot, if I put the fuse in and it blows right away or burns right away, I know I have a direct short to ground. Well, that can be a pain to diagnose, and you can go through a whole lot of fuses. So what I'm going to do is I'm going to guess the nominal amperage or current flow through that circuit. Now, if I have a 30 amp fuse, how can I guess the average or nominal flow of current? Well, if I'm an engineer, I know this fuse is actually a resistor. And so it's not actually limiting current. It will limit current, but it's only going to limit current to the ampacity of the resistance through here, which is actually a lot more than 30 amps. But what it does do is it gets hot because it's a resistor. So if this is a 30 amp fuse and I'm running it a nominal current of, say, 25 amps, this fuse is still going to burn. It's going to take it a long time, but it'll still burn. Or it will become unreliable due to heat cycling. So as an engineer, the best way to solve that problem is to go ahead and use a bigger fuse and wires that can handle the current and things like that. So in a 30 amp circuit, I'm not going to expect much over 15 amps flowing through this. That's important to understand, because if I hook a 4 amp test light in place of the fuse, and that circuit's normally pulling 7, 8, 10, or even 15 amps of current through there, what's going to happen is it's going to look like a dead short, because it's pulling more current than it takes to light that light fully. So that's important to understand, and So I'm going to kind of go through the process of how I set up the right test lamp for the right situation. So first thing I'm going to do is get my current probe set up. Okay, show you, get this set up. This scanner is pretty neat. It lets you sideload apps. So not only do I have the scanner on here, I've also got the Curian N2 software on here, so I can set this up. I'm going to use the 20 amp setting on the clamp, which is 100 millivolts equal, or 100 millivolts equals an amp. So that's the setting I'm going to use here. So I'm going to go amp clamp meter mode. 1 amp equals 100 millivolts. And I'm going to set that up on the 20 amp mode. And let's verify by lighting our light. And there you can see that one single amp is 4.61 amps. So now, say I want to, I want to test this higher amperage fuse. 4.61 is probably okay for a 10 amp fuse. That's about 30, little over 30%. That might not be enough, but it's probably enough for a 10 amp fuse. But if I want to do a 15, and if I want to do a 5, I might want to use something a little smaller, but it'd be even okay for a 5 because I know it's going to handle up to the fuse rating. But say I need to do this 30, and that's not going to work for me. So how I'm going to overcome that is running another bulb parallel. And by parallel, I mean I'm going to run the ground to the ground and the positive to the positive to increase the amperage or current. I like to use those terms interchangeably. If you get offended by that, just quit watching. But otherwise, I don't do it on purpose. I don't mean to confuse anybody. So now, this would be kind of a pain in the butt. So now you can see that amperage goes up significantly higher. So now the current flow is at 7.86 amps. And now on a 13 or a 30, that still might be a little low. It's probably acceptable, but if I determine that the normal load on that fuse is, say, above 10 amps, I'm just going to grab another lamp, wire it in parallel like that. Well, and really, when I'm doing testing, I'm going to be a little better about it. I'm not going to use jumper wires. I'll probably use connectors, but that's how I get there. Sometimes I use jumper wires. It all depends on how big of a hurry I'm in and how stable the setup needs to be. But a lot of times I'll just use jumper wires, get it all set up, and get to work. So sometimes they can look a little messy. But now I'm up to 7.4 amps, and I just keep adding parallel circuits until I get to the amperage or current flow that I need in order to make this usable. So that's how I determine it, though, is I always try to go to at least 40%, if not half of the fuse. Sometimes, very rarely, you'll find a circuit that is loaded to 60%. Some of that's probably lazy engineering, or they engineered the circuit and then added components later. But if I find a circuit that I'm having trouble on or weird issues with, I will up the current of the lights that I put in place of the fuse. So very rarely will I go more than, say, 80% of the fuse rating. There's a few rare times where I felt it necessary to go at the fuse rating or even slightly higher. But, once you're starting to play with that high amperage, and 10 amps is no joke. I mean, you can start a fire with a 20 amp circuit. So use caution when you're doing this and make sure you understand what you're doing. But this is what I use to find short to grounds, and sometimes I'll just use an amp clamp in this situation, or I'll actually monitor the voltage drop across the load or the lamps, and I'll measure the battery voltage at the same time, and then wiggle and jiggle wires, because the voltage drop is only going to match battery voltage when you have a direct short to ground. Otherwise, if you have any resistance, the voltage drop across that light is going to be significantly lower than battery voltage. So that's important to understand, or the feed voltage, if that makes a little more sense to you. That's important to understand. I also want to show you what happens if you hook the lights up in series, which is not really the right way to do it. But if you make a mistake like that, then you're really going to have weird problems and not understand what you did wrong. So I want to just show that quick. So now, if I take the positive and put it over here, this light's going to light. I'm getting my 3.76 amps there, and then I'm going to put this on the feed side of this one. So now it's positive in here, out here, through this bulb, out here to ground. And you can see how that actually reduces my amperage. Even though both lights are lit, they're dim, there's actually a 6-volt drop, or half the feed voltage, at each one of these. Or, pretty close. The resistance is relatively close, but not exactly the same. So there's going to be different voltage drops there. But you're seeing the amperage is actually less than lighting one light, running them in series. So if you want to increase the current flow, then you actually have to run them parallel. And you can see that amperage goes back up to 7.89. So then we just keep adding parallel loads until we get to the amperage we want. Now you could set this all up in a fancy box, or you could just have a handful of headlights laying around. It doesn't really matter what you do as long as you achieve what you need to. This is important, and you'll see in the video why it's so important. So I know this is a long explanation to get to a video that's probably shorter than the explanation, but it's important that you understand what I'm doing and what I did wrong. So you can see what happens if you don't load these at an appropriate amperage using a current limit resistor. You can really cause strange issues, chase your tail, waste a bunch of time, and we don't want that. So I hope you see my mistakes in the video. I hope you understand that, and don't make that mistake. You probably still will anyway eventually. You get busy, and sometimes you forget the little details. All right, I'm dealing with a short to ground on a 2004 Super Duty F450. Here's a circuit I'm dealing with. It is, I don't know if we can get that to look through the computer, but it's fuse 18. It powers the brake pedal position switch, which goes through the multifunction switch to the rest of the taillights. The indicator flasher, it also powers, and it either goes through the hazard circuit to the multifunction switch, or it goes through the turn signal circuit to make the turn signals flash. So I'm going to show you what we got going on here and how I'm set up to do this. So inside the vehicle, there's the fuse 18 spot. I've got 2 leads tapped into it. I've got this headlight in place of the fuse. So that's going to work as a current limiting resistor. And then I have an amp clamp over that. I know this headlamp, the maximum amperage or current allowed to flow through this, because it's a resistor, is 4 amps. So if I have a short to ground that has a less resistance than this bulb. It'll light the bulb nice and bright, and if it'll pass 4 amps through that short to ground, I'll have 0 volts on the other side of this and a maximum amperage or current flow of 4 amps. And I ran into a problem, so I want to show you why. I also am using the N2 here to set that up to graph. Ignore the glitches. That's pretty normal. So just ignore the glitches. You'll see what's going on here. But anyway, so I have that set up. I'm going to put on my left turn signal, and you can hear the relay buzzing, and you can see this is going up to about 4 amps. And you can see, so that's pretty well a dead short. See what happens when I go put on the other turn signal. Since all those other lights won't pull 4 amps, it gives me a nice on-off, on-off. But this makes it pretty hard to diagnose. Again, ignore the glitches. But that makes it pretty difficult to diagnose. So how we're going to do that is we're going to, here, I'll show you again when I put on the left. It's just a short to ground. And what's happening is as that switches, the voltage drops to 0 and the flasher doesn't work anymore. So that's what's going on there. And you can see when I switch it to the other side, everything works as it should. So what we're going to do is we're going to tap into the relay location so I can check for a short to ground on this circuit. And I'll show you what that looks like. Okay. So since tapping into this fuse here was a little bit of a challenge and was making that flasher relay work, so we couldn't really diagnose this system, what we did is we got rid of the flasher relay, and I put a 20 amp fuse back in here, and I'm getting my feed here, and then jumpering it through the headlight on the other side of this to the multifunction switch that feeds the left and right turn signals depending on where the switch is applied. So now I'm going to show you what that looks like. If you can see that diagram. Alright. So that's what we have way up in there. I don't know if you can see the test leads go way up in there, but that's where the turn signal relay is. But same thing, ran through the headlamp. There's a fuse in the place now, but this will still limit the current so we don't keep blowing fuses. So now I've got my amp clamp on it. Got it hooked up to the N2 over here. I'll go ahead and shut my headlamp off so you can see that. This is the right turn signal, and we're at about 2 amps. That's the left turn signal. We're at about 3 amps. So we know we don't even have a direct short to ground. We have a low resistance to ground, not a direct short. So that makes it a little more challenging, but still, this is the best way, in my opinion, to figure out this problem. So another tip for you, since we don't have a direct short to ground, there's actually voltage left on the other side of this light, which is awesome, because that means we can verify what components aren't working. So let's take a second. We'll walk to the back of the truck, and my left turn signal's lit up. The ones up there are not. Let's check the front of the truck. Front of the truck, my left turn signal's lit up. Pretty dim though, but it's lit up. So let's see what the other side looks like. The side we know we don't have a short on. We got the right turn signal turned on. That one's nice and bright. That one up there is nice and bright. This one's out. So we know we don't have a short here. This probably just has a burnt out bulb. This one was pretty dim, so we're probably going to check it anyway. But the first place I'm going to go is this one that doesn't work. somebody's got this all pulled apart here, so it'd be really easy to test at. But that's where I'm going to start. It's testing right there. Might even just cheat, throw that amp clamp on right here. See if we have any current flow through this. So that's what we're going to do next. And see what we get. So we got the left turn on. You can see we have 2.9 amps. I'm going to take the clamp off, grab the N2 and move it. And I'm going to see if I can get that wrestled in there. Okay, so we got that clamp on there. And the bulb's not working, but that's okay, because we have essentially 0 amps on that circuit. So I'm not going to worry about that as the short. So the next spot we're going to go is to that half-lit light in the front and see if we have a short to ground or a partially shorted bulb. Alright, well, that's weird. So we replace this bulb, and we have almost 3 amps on the right side. But when I replace this bulb, that turn signal up there turned off. Weird. So check this out. This side's off. Left turn. That bulb's out. Wasn't working before either on this side, right? This bulb's working. That bulb's working. That bulb's out. Watch what happens when I take that bulb out of there. That bulb comes on. See? Pretty neat. What's even more cool is I put the bulb back in, that light comes on, and that one stays on. Turn the turn signal back off and back on, the bulb's out. That one's on. Neat. But pretty dumb. So I'm going to go ahead and guess that wherever that is, however they splice into that, might be the whole problem. The other side, I presume, is the same way, because that one stopped working when I replaced that bulb. But I'll do some digging and let's see what we find. Okay, I'm going to explain this really quick, mostly because I'm running out of battery and memory, and I'm annoyed because that short to ground ended up being intermittent. Put all the bulbs back in, put everything back together. I can't get more than 7 amps of current through that fuse now. That's with the brake and the turn signals on, so I can't recreate the issue, unfortunately, but now at least all the lights work. So why the weirdness? Those auxiliary lights up on the headache rack are wired into the left and right trailer turn relays, and those are controlled by the power feed from the left and right turn signal where I was tapped in. So I'm going to try to make this make sense to you really quick, and then I got to move on. So I was tapped in at the indicator flasher here, and with a 4 amp test lamp. So that works as a current limiting resistor. Well, even though we weren't pulling the full 4 amps through there, the 3 amps that the rest of the bulbs take to run was enough to limit the current flow to the control side or the solenoid side of the relay, not allowing this relay to turn on. As soon as I pulled the bulb out, it dropped down to 2 amps. Then it allowed enough current to flow through this coil to actuate the switch in the relay. And that's what was turning on that bulb. And that's why once it was on, I was able to put the bulb back in because it takes a lot less amps to hold this, or a lot less current to hold this in than it takes to pull it in. So that's what's going on there, is I pull the bulb out, it pulls the relay in, turns on the other light, put the bulb back in, it stays on. Shut the switch off, turn it back on, and then this is stuck again because there's not enough current flow through here. So it was a problem I created. Once I put it all back together, it was just fine. So another thing, just overlook the silliness sometimes and focus on the problem at hand, especially if everything's tore apart. So it can be tricky sometimes, but anyway, that's why it was doing that. We still have a short to ground intermittently, presumably. Couldn't find anything obvious. Wiggled and jiggled and shaked everything. Everything's normal. So, unfortunately, I got to bail on this one, unless the guy wants to give me a whole lot of money and leave the truck for a couple weeks. So, that's the end of this one.